Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today's battlefield isn't just about firepower, it's about what you can hear before you ever see it. And that's where acoustic vector sensors, or AVS, come in. In modern warfare, sound has become a powerful source of intelligence. Every drone buzz, rocket launch, engine hum, and sniper shot produces a unique acoustic signature. If you can detect it, you can act on it and possibly survive it. That's the premise driving the global adoption of acoustic sensor networks. Unlike conventional sensors that rely on line of sight or radar, AVS listens quietly, passively, and in all directions. And in places where radar can't see, like behind hills, inside cities, or beneath the waves, that can make all the difference. These sensors work by triangulating the source of a sound. Whether it's a drone, a tank, or a sniper rifle, each emits a recognizable audio footprint. AVS systems don't just measure volume, they analyze pressure, direction, frequency, and motion to pinpoint the location of a threat with surprising accuracy. And here's what makes them game-changing. They operate in real time, they don't emit any signals that give away their position, and they can be mounted almost anywhere on vehicles, drones, ships, or even on soldiers. Take the Russia-Ukraine war, for example. Both sides have used drones heavily, not just for surveillance, but as loitering munitions, basically flying bombs. Radar can sometimes miss these small, low-flying threats, but acoustic sensors pick up the unique whir of a drone's propellers and feed that data into AI-driven systems that classify, locate, and even track targets. But AVS isn't just for detecting drones. They're used to detect and locate gunfire, artillery, mortars, submarines, and even tunneling activities underground. In urban warfare, they can spot snipers by listening to the shockwave of a bullet and backtracking it to its origin, all in under 2 seconds. That's where companies like Microflown Technologies are leading the charge. Their acoustic vector sensor tech is smaller than a sugar cube, but it can identify and localize hostile fire within 1 degree of accuracy. Mounted on a vehicle or drone, these sensors provide 360-degree battlefield awareness without relying on GPS or active signals. How? It's pretty fascinating. These sensors detect the movement of air particles, something most microphones can't do. 2 heated wires measure how sound waves disturb airflow, generating data that reveals both the direction and nature of the sound source. And now, with machine learning baked in, AVS systems are getting smarter. They're being trained to tell the difference between friendly and hostile vehicles, or between fireworks and real gunfire in urban environments. Even underwater, hydrophones and vector sensors are being deployed to detect submarines and unmanned underwater vehicles by listening to their mechanical noises. And in naval warfare, silence is deadly, so being able to passively detect movement is a huge tactical advantage. Of course, AVS networks face challenges too. Environmental conditions like wind, humidity, and terrain can distort sound waves. Urban noise makes it harder to isolate targets, and large deployments require efficient power use and low latency data transmission. That's why the future is about sensor fusion, combining acoustic data with seismic sensors, infrared cameras, and AI-based analysis to give forces a more complete, real-time picture of what's happening around them. We're already seeing this with vehicle-mounted AVS systems that provide full spherical acoustic situational awareness, identifying threats before they come into view. And UAVs equipped with AVS can fly over the battlefield, detecting hostile activity that other sensors might miss due to smoke, fog, or camouflage. What we are witnessing is a revolution in passive detection. Instead of watching, we are now listening. And on a modern battlefield, that can be the key to survival. As technology evolves, acoustic vector sensors are quietly becoming the ears of the digital battlefield, delivering precision, stealth, and safety in a chaotic world.